This one's a part of my series, Research Topics for Aspiring Scientists, where I point out gaps in the literature that can be filled. This idea is one of the most low-hanging fruit out there, and it's evaluating rapid antigen testing. Now, we have an ongoing problem where we know that rapid antigen tests are getting less sensitive over time, and this is likely due to the emergence of new variants of COVID. But we don't know exactly which spike mutations or which nucleocapsid protein mutations actually impact these tests. And then not only what mutations impact the tests, but how sensitive the tests are when they're responding to those types of mutations. So the first phase of this experiment is really fun, really easy. You take a wide array of COVID variants from the original Wuhan to the most recent current variants, picking out the major strains. You could pick Delta, you could pick original Omicron, you could pick BA4, BA5, BA2, BA2.86, etc. And then you do dilution concentrations of each one of these variants. And you can see, one, are they showing up at the test? Two, what concentration do they actually show up on the test? And then three, you can correlate the signal strength, how dark the line is on the rapid antigen test, to a concentration. And this is assuming that you do all with one single test like FlowFlex, which is one of the best tests out there for rapid antigen, in my opinion. But then you can also do the same exact experiment on things like iHealth and BioNext Now, etc. And what we would expect to see is that we have incredibly high sensitivity with the original variants that the tests were calibrated for, and then we're going to see a decline over time. But then it's going to be interesting to see what types of variants have the biggest decline. So maybe it dips really far down and then pops back up with higher sensitivity with later variants. And that's where the magic happens, because you can start to correlate these dips or spikes in sensitivity with specific spike mutations that are associated with different variants. And not only that, but you can see with different variants and different spike mutations or nucleocapsid protein mutations, what concentration is going to be associated with that initial test signal production. That way we can do a few things. We can evaluate which tests are holding up sensitivity over time, which ones are not, in addition to what types of mutations that we see, if we see them in current variants, are they going to show a decrease in sensitivity of the test? And this would be immensely useful information for people to have.